All right, good morning, everybody. This is Mr. Chestnut. Today is December 14th, 2020. Um, Today is the first day of our remote instruction again. I hope everybody is safe and sound at home. We need to keep moving forward. We have work to do. We have the curriculum to cover. One day this week, later on, either Thursday or Friday, we're going to be taking the test on this unit. It could occur as early as Monday morning and I'm sorry, Wednesday morning, but it's either going to be Wednesday, Thursday, or Friday. Sorry, I was getting messages. I get distracted. So what I want to do is right now is I want to start to go over the multiple choice review packet with you. And what we're going to do right now is we're going to start with question number one. Oh, I'm sorry. Before I do that, I want to make sure that you're taking attendance in Teams on a daily basis to record your attendance. Thank you very much. All right, so question number one says, in the absence of a net force, meaning some sort of external force, a moving object well, according to Newton's first law of motion, a body in motion will stay in motion. So the answer is that it will move with a constant velocity. Let me see if I can highlight that answer. Yes, I can. Great. Okay, so question number two. If a cat is sleeping on a table, the weight of the cat pushes down, but the table pushes back upward, equal and opposite. So we have the weight and what we call the normal force. So really, in terms of overall forces, the forces cancel out, and that net force will be equal to 0. All right. So keeping with Newton's first law of motion, we can see that when the engines of a rocket ship in deep space are turned off, it will, according to Newton's first law of motion, objects in motion will stay in motion. There's no friction in space, so it will move with a constant velocity. Um, in order for that rocket ship in deep space, far from any other objects, to move in a straight line with a constant speed, it must exert a net force that is. Now, let's think about this. If it's moving at a constant speed, the net force on it actually is going to be equal to 0. Okay, we're going to keep moving forward. If the book on the dashboard of your car suddenly flies towards you, the forward velocity must have be increased. Okay. Number 6 says a boy rides a bicycle at a constant velocity. What can we say about the object? If it's moving at a constant velocity, there will be no net force acting on the object, which means the net force equal to 0. If there was a net force acting on the object, it wouldn't be moving at a constant velocity. Rather, it would be accelerating. So the answer is 0 in that case right there. We're going to keep on moving forward. I'll do 7 and 8, and then I'm going to hit pause. 7, 8, 9, and 10, and I'm going to hit pause for a second. A passenger standing in a moving bus facing forward suddenly falls forward. That indicates that the bus slows down. Passenger standing in a moving bus facing forward suddenly falls backward. That indicates that the bus speeds up. Passenger standing in a moving bus facing forward falls to the right. That indicates, that the bus turns to the left. That's going to be E. Okay, those answers ran together. Sorry about that. Um, we can see that the acceleration of the object is proportional to the force acting on it. The bigger the force, the bigger the acceleration. The smaller the force, the smaller the acceleration. The next question wants to talk about the acceleration of the object is inversely proportional to. We don't typically use this term. We didn't use that term a whole lot, but inversely means gets smaller. Inversely proportional means if one variable gets bigger, the other gets smaller. So let's think about this. As the mass gets bigger, what happens to the acceleration? The acceleration will be smaller due to increased mass. So the answer is that acceleration of an object is inversely proportional to its mass. Okay, question number 12, I want to skip for now. Question number 13 says that a loaded truck collides with a car, causing huge amount of damage to the car. What's true about the collision? The forces are going to be the same, equal and opposite magnitude, okay? Meaning that the car and the truck will hit each other with the same exact force. Question number 14 is jumbled on my page right here. Action-reaction forces are going to be equal and opposite, equal in magnitude and opposite in directions. So the answer is going to be equal in magnitude and opposite in directions. I can't see the answers there on that one because it's all run together. I'm going to move on. A car traveling at 40 meters per second strikes a mosquito. What can we say about the forces compared to each other? They both will hit at the same force. Okay. A railroad wagon pushes down on the railroad with a force of 200 kilonewtons. Okay, that means if the railroad wagon pushes down, that means that the earth is going to push up. Hold on, So the railroad pushes up because the rail car is pushing down. The opposite forces, railroad pushes up right there. We're going to skip 17 and 18 for now. Okay. Number 19, if a soccer ball is kicked with a force of 13 newtons, the soccer ball hits the player with the same equal and opposite force, 1300 newtons. We should realize that mass and weight are different measurement units. Okay, mass is the amount of matter. Weight is the force of gravity acting on the object. We should see that if the acceleration due to gravity is higher on Jupiter than the Earth, that means that the mass would be the same, but the rock would weigh more. The mass would be the same, but the rock would weigh more. There we go. A hammer and a pebble are dropped simultaneously. We're going to skip 22. We don't need that one for this particular exam. The elevator mass is pulling upward at a constant velocity. What can we say about the tension? That means if it's moving at a constant velocity, that means that the tension is going to be equal to the weight right there, okay? Because there's no external force right there. An elevator mass is pulled upwards by a cable, and the elevator has a positive increasing velocity, meaning that means it's going to accelerate upward. That means that the tension in the cable will be greater than the weight, which is mg. Okay, so that leads us to the end of the multiple choice review. Tomorrow, what I'm going to do is I'm going to solve some more of the free response problems for us, and that will prepare us for the test. As I said before, the test will either occur on Wednesday, Thursday, or Friday, depending upon how fast we get through the material tomorrow. I will make a decision on that tomorrow. Okay, any questions? You can message me throughout the day. I'll be available through email and the Teams app. If you have a question that you can't answer through that, message me and ask me for me to give you a ring, and I will through Teams. Okay, thank you very much. Have a great day. Bye bye.